Welcome to iLecture Here's a list of the additional amazing scientific pieces of equipment that they have on board the Messenger spacecraft that allowed us to learn so much about the planet Mercury. So in addition, they also had what we call a magnetometer, which is a device which is able to measure the strength of the magnetic field. Now, this was placed at the end of a long boom. In this case, the boom was about 12 feet long, about 3.4 meters long. And they did so to minimize the interference of the magnetic fields created by the electronic equipment on board of the spacecraft itself. So they want to put as much distance as possible between the electronic equipment and the magnetometer, so that what it would measure was primarily the magnetic field of the planet, not so much the magnetic field of the equipment on board of the spacecraft. So they used the magnetometer to both detect the location, the direction, and the strength of the field all around the planet. Then we have what we call the MLA, which is the Mercury Laser Altimeter. So they also wanted to get a very good reading of the altitude of the surface of the planet all the way around, the craters, the indentations, the mountains, the valleys, and everything. And so what they did was they would beam down a laser beam and then measure the reflected beam, and they could then figure out exactly the distance between the spacecraft and the planet's surface. So they would do that all around the surface as they go around when they went around the surface for years, and they got a very good altitude map, so a very accurate altitude or relief map of the surface of Mercury doing that. The accuracy of that laser beam is just amazing. I think they can get it down to just a few inches of accuracy. They also had what we call the MASCS, the Mercury Atmospheric and Surface Composition Spectrometer. So what they do there is, instead of using X-rays or gamma rays, in this case they use UV rays. So again, they try to use every possible band in the RF frequency. So in this case, they used a UV spectrometer to study the atmospheric particles primarily. So to get a feel of what the atmosphere is made of and the abundance of the atmospheric particles, they used UV spectrometry, because those particles in the atmosphere would receive the energy from the sun. Energy from the sun contains UV radiation. It would elevate the electrons inside the particles to higher levels, and then they would come back down, and the spectrometer could then see the jumping up and down of the particles in the emission spectrum, and therefore look for the abundance of the various elements within the atmosphere. And of course, the atmosphere is pretty volatile in Mercury. It isn't of uniform density and uniform consistency, and so they were trying to learn where the elements would be different at different parts of the planet in the atmosphere. Also, they looked on the surface, and they looked primarily for titanium and iron, which again would have UV signatures that we could measure, and that was done with the UV spectrometer on board to the spacecraft as well. So our next device on board is called the EPPS. It's called the Energetic Particle and Plasma Spectrometer, which includes the FIPS, which is a fast imaging plasma spectrometer. In other words, those devices are able to detect charged particles. Plasma is basically material where the electrons are stripped away, therefore ionized, and so therefore the mass-charge relationship can be detected by these spectrometers, and they're used therefore to detect particles coming from the surface that are ionized. And so again, these are not detectors that detect electromagnetic radiation such as gamma rays, X-rays, or UV radiation, but simply the particles themselves. And then finally, we have what we call radio science equipment. This is simply kind of like a radar, where we're sending electromagnetic radiation to the surface. It bounces back, and we're measuring the frequency shift based upon the motion of the spacecraft. Now, if the spacecraft is moving perfectly still at the same altitude, then the shift would not be existent. But because the differences in gravitational pull over various portions of the surface, because the different densities near the surface of the planet, and also the different densities of the core and whether or not the core is liquid or solid, we're able to see the very slight fluctuations in the motion of the spacecraft. And that is done by measuring the changing shift in the radio signals coming back from the surface that we beam down to the surface. They come back, we see the constant changing in the shift, and based upon that, we're able to calculate the gravitational pull of various portions of the planet and the internal structure to some extent. So we use that to measure the gravity and the state of the core using these signatures, the fluctuations in the radio signals that we send down to the surface, and they're then reflected back. So imagine that. A single spacecraft, basically the size of a small Volkswagen, can detect all these various things and allows us to get a very good global picture of what Mercury is like, what the consistency of the materials are like in the atmosphere, what the magnetosphere is like, what the interaction between the solar wind and the magnetosphere is like. It's quite amazing how we can do all that with just one spacecraft, millions and millions of miles away. But it was done, it was a success, and we'll learn more about some of the major discoveries that we discovered with all this fancy equipment. So stay tuned and we'll explore it some more.